Scientific notation. You'll also find this referred to as standard form in some textbooks. We want to write the following numbers in scientific notation. Now, in scientific notation, a number is always written in the form a times 10 to the power n, where a is always a number between 1 and 9.99999. So we could write that as a being between 1 included and 10 not included. N is always an integer. So that's a positive or negative whole number. So how do we do this? Well, here we have 39070. If we think about this number, the decimal point is currently just here. If we want the a part of our number to be in this range, the decimal point needs to be just here. In order to get it there, we have to go 1, 2, 3, 4 decimal places. So in scientific notation, we write 3.907. We don't need to put the last 0 down. And then we need to decide on the power that goes on the 10 here. Well, in this case, we want 1, 2, 3, 4. So it's 4. It's a positive 4 because the original number is a number that's greater than 10. If the original number is a number greater than 10, then the power would be positive. So if we look at this one here, 0.0069, what we need is for the decimal point to actually be here, so that we can write our number in this form. So we go 1, 2, 3 places. So we have 6.9 times 10. Now we went 3 places, but this time it's negative 3 because our original number is less than 1. So if the original number is more than 10, you'll end up with a positive index. If the original number is less than 1, you get a negative index. So for this example here, we have 4, 5, and then 1, 2, 3, 4, 5 zeros. Now this is an integer. The decimal point's here, but we wouldn't normally write it. And we want it to be there so that we just have the one non-zero digit in front of the decimal point. So we've got to go 1, 2, 3, 4, 5, 6. And our original number was more than 10. So that's 4.5 times 10 to the power 6. Now we have 0.000704. In this case, we've got a number less than 1, so we know that our index is going to be negative. And we can actually see the decimal point this time. But we want the decimal point to be just there. So 1, 2, 3, 4 places. So that's going to be 7.044 times 10 to the negative 4. We want to write the following numbers as ordinary numbers, so we're starting with 5.3 times 10 to the 6. Now with this one, because the index here is positive, we know that the original number was more than 10. So we're going to move the decimal point 6 places in such a direction as to make the number bigger. In other words, we're going to go this way. 1, 2, 3, 4, 5, 6. So the point is going to need to go just here. All of the blank arches get filled with zeros. So we have 5, 3, and then 1, 2, 3, 4, 5 zeros. And of course we wouldn't normally write the decimal point. Now it's worth pointing out that 10 to the 6 is a 1 with 6 zeros. It's a million. So sometimes people look at this as doing 5.3 times 1 million. That's what 5.3 times 10 to the 6 means. But think about what you do when you times by a million. You move the decimal point 6 places, exactly what we did before. Here we have 1.26 times 10 to the negative 3. So 1.26 times 10 to the negative 3. The fact that this is negative tells us the original number, when written as an ordinary number, is going to be less than 1. So what we need to do is move the decimal point 3 places in a direction that will make the number smaller. So 1, 2, 3. The decimal point would go here. The blank arches need zeros, and we put a 0 in front of the point. So our answer is 0.00126. Let's underline the answer over here as well. Now, from our index laws, 10 to the negative 3 is 1 over 10 cubed, which of course is 1 divided by 1,000. So that's another way that people sometimes do this. They do 1.26 and divide by 1,000. But think about dividing by 1,000. What do? You move the decimal point 3 places to the left, which is exactly what we did.